Remember, stoichiometry lets you go forwards or backwards in a reaction. We can relate two reactants, two products, one reactant, one product. So here's a problem where we're trying to figure out information about this reactant, knowing how many liters of oxygen were formed. So this is not standard temperature and pressure, so this will involve two steps. Step number one, we're going to figure out how many moles of oxygen gas we formed based on the 4.58 liters of oxygen gas being formed. So this step involves one set of conditions. We're going to use PV equals nRT because we want to solve for the number of moles. So we divide RT over to the left to give us the number of moles. The pressure P is 745 millimeters of mercury. And we want to convert that right away to atmospheres to cancel with the gas constant R. So 760 millimeters of mercury equals 1 atmosphere. The volume V was 4.58 liters of oxygen gas. Gas constant R. And the temperature T was 308 Kelvin. Double check our units. Millimeters of mercury cancel, liters cancels liters, atmosphere cancels, Kelvin cancels Kelvin, and we're left with inverse moles in the denominator, which is the same thing as moles in the numerator. So this number of moles is 0.1775 moles of oxygen gas. We want to figure out how many grams of silver oxide decomposed to give us that many moles. So now step number 2, how many grams of silver oxide had to decompose to give us 0.1775 moles of oxygen gas. And the mole to mole ratio from the balanced chemical equation is 1 mole of oxygen came from 2 moles of silver oxide. And we want to turn that into grams, so we need the molar mass. And silver oxide's molar mass from the periodic table, 231.74 grams per mole, gives us an answer of 82.3 grams of silver oxide.